Welcome to Makerspace for September 2020. Our topic today is the periodic table of the elements. Most of our Makerspaces in the past have focused on the technology portion of STEM, where STEM stands for science, technology, engineering, and mathematics. But today we're going to focus on the science portion as we learn about the periodic table. Now this is an introduction to the periodic table. This is not going to replace a high school chemistry course. On the other hand, you'll have a chance to learn a little bit about it, and we're going to do some things with a video game and with some graphics pages. So we're going to have an introduction to a very complicated document. We'll start by asking you to look for your take-home package, your grab-and-go package that the library provided. It should have a folder like this that has a sticker on the front with a copy of the periodic table. It would include a take-home paper that looks like this, and we're going to be looking at this a lot during our workshop. There's a page that says websites for further study that has several web addresses that you may find interesting. Then your own copy of the periodic table with enough information for our discussions for today. There should be some graphics pages that have information about each of certain elements, as well as some graphics to help you remember or relate to those elements, and either some colored pencils or crayons to work with. So if you've got all the parts, let's get started by looking at your take-home paper. And on your take-home paper, the first thing I'm going to ask you to do is to notice there's a place for your name and the date, so that you will have as a record in the future of what date and time that you worked on this. And we usually start with talking about safety in our Makerspace workshops because safety is important. In this case, doing chemistry and reading about chemistry are different. If you do chemistry, you need to follow safe practices. But since we're going to be reading about chemistry and doing it on the computer and on a website, then you probably don't need to have goggles or a white lab coat or wild scientist hair. You can get by without doing anything from a safety standpoint for the workshop we're doing today. The first topic next, or the next topic on our page says, what is the periodic table? The periodic table is a way to organize a lot of information so that it can be found easily and quickly. It's also a visual map that relates some information to other pieces of information, and that it lists each of the elements. And we'll talk about what an element is in just a few minutes. It's also a document you're going to see in every chemistry classroom. Which leads me to the next question of who uses the periodic table. Well, chemists definitely use a periodic table, and physicists and engineers, but the biggest users of the periodic table may be chemistry students. And if you are planning on graduating from high school in Louisiana, then you will perhaps be taking a chemistry class. Especially if you are on the Tufts University curriculum path, you'll be expected to take 1 biology and 3 science electives, and certainly chemistry is one of the very popular electives. So seeing the periodic table in today's workshop will give you an introduction to it, and when it shows up later in a class, you'll already have some of the information to work with. While I'm on the cover of our take-home page, I want to say thank you to CLECO and to the library for making it possible for us to have this workshop. And with that, I'm going to ask you to open up your take-home paper and look on the inside. On the inside of the take-home paper, starts off with talking about what are some other tables, because we said the periodic table is a table. Well, you probably used an addition table when you were younger. And with an addition table, you can look up things like 4 plus 5. You can look at that on this table and you can find that answer. When I was young, we used to have square root tables in the back of our books. We all have square root functions now on our laptops and our cell phones and various other electronic places. But a square root table is another way of having information in a table. With the table that's in your take-home paper, you could look up the square root of 5, or if you wanted to know the square root of 28, you could calculate that because you know that 4 times 7 is 28, and the square root of 4 you already know, and the square root of 7 you can find in your table. So that table has a lot of information, and I just trained you on how to use it. by knowing the number that you want to know the square root of and then looking it in the table. So now the periodic table is also a way of having a lot of information in one place. One thing that you'll find is that there are a lot of different versions of the periodic table. The one that you see in your classroom in high school may look different from the one in a textbook. If you look on the internet, you can find dozens of variations. But they almost all have some of the same basic information. You can see the one in your take-home paper has the symbol and the name for the element and the atomic number, and this one has the atomic mass. The atomic number is very important because that is the number of protons in the nucleus. The other thing I want to talk about is to mention that the periodic table lists every element that we know about. Every element. The elements is a way of identifying what makes up things. All of the things that we know about in the physical world are made of elements or compounds that include those elements. So all of the elements are listed on the periodic table, and there's only 118 of those elements. But we're not going to study about all 118 of those today. Instead, we're going to talk about some families or some groups that bear similar properties. So I'm going to ask you now to look on the top right of your take-home paper where it shows you that shape of the periodic table. And you'll notice that there's a number above each of the symbols. It starts off with number 1 on the left. That's because there is 1 proton in hydrogen. If you have 2 protons, you don't have hydrogen anymore, you have helium. And that's the 2 on the right. And that atomic number is the way that they've identified where to put the elements in the periodic table. So as you read across the periodic table, on the left you've got 1, and on the right is 2. Then back to the left, the next element is lithium with 3, and so on. And with that as a background, I want to introduce you to a simulation where we're going to make an atom. On your take-home paper, if you look where I'm pointing with my pointer, you'll see where it says Game, www.phetcolorado.edu. If you select Chemistry, General Chemistry, and Build an Atom, it will bring you to this web page. And this is the model that I wanted to share with you. So on this page, it says Build an Atom right here. So I'm going to select that. And then click in the middle where it has the arrow pointing to the right. I'm doing this on a laptop, but you may find that it also works just as well on a tablet. And the PHET simulation will load. There is no cost to run this simulator. You do not have to register, you do not have to sign in, you do not have to have a credit card. This is being funded by a group associated with the University of Colorado, and so you won't have to do anything to use it other than just turn it on and look it up. So you want to select the atom, and then select net charge so that that's visible, and click on the show stable unstable. So right now in the periodic table there's nothing highlighted. So we're going to grab a proton and put it in the center of our atom, and now it says we've got hydrogen, but it says that it's an ion, and you can see where hydrogen has become highlighted within this table, and we've got a plus net charge. So I'm going to give myself an electron, and now I have a neutral atom. So, and it is stable, so I now have hydrogen. I mentioned that the atomic number was the number of protons in the nucleus. So if I add another proton, it's no longer hydrogen, it's now helium, and you can see in the table where helium is now highlighted, and we have the symbol in the middle of the table reminding us that this is helium. But this is unstable, so I need to give it a neutron to help it be stable. So now we've got a stable, oh, but it's still an ion. So I need to give it a negative electron. I'll put my electron over here. The electron jumps to the second orbital. That'll be important later. So now we have helium as a neutral atom, and it's stable. What if I added 3 more protons? And now it's really unstable, boron, so I need to help it become stable. So I'll give it some neutrons to get it stable. We're stable. You can see I've got the same number of protons and neutrons, but I am not balanced on charge. So I need to give it some more negative electrons. I'll put those in the middle. No. Notice that they jump to the second orbital level. And now I have a neutral atom with boron. Now that you've seen how this works, maybe you could make carbon. Or you can make any of several different elements. And you'll notice that the symbol changes and the element within the periodic table becomes illuminated. So this is how you can use this simulator. I hope you enjoy it. Okay, so now what you've had a chance to do is see how an element might have a different number of protons, and that makes it a different element. And you've also had a chance to see how the electrons only go to certain places. You can't put an electron anywhere. The first two electrons go in the first orbital, and the next ones go in the next orbital, and that is the reason for this shape of the periodic table that some people have said looks like a Tetris game that didn't get finished, because the first orbital represents the first row. The second orbital represents the second row, and then the third orbital, and then the fourth orbital has different ways of filling those orbitals. So if you want to learn more about that, you can, but for right now, the answer to why does the periodic table look unusual is because of the atomic structure. So if somebody asks you about that, now you've got an answer. The next thing I wanted to mention is on the take-home paper, it says some familiar elements near the bottom of the inside page. And at this time, I'd like you to look for your graphic package. It probably looks like this. And it says coloring book on the front of it. The reason I'm asking you to look for that is because this has one page for each of several elements that have been identified. And on those pages, it has some graphics that might help you remember what the element does or how it's involved in our life and the world, and also a bunch of information. So what I did was I used some colored pencils and made mine a little bit more interesting. And you might want to use the crayons or the colored pencils, or maybe just skip that and just find the words interesting to read. Some of the interesting information I got out of this is listed in the table at the bottom of your take-home paper, and I'll let you read that on your own. So now I want you to turn the page over, and we're going to go to the back of the take-home paper. And on the back of the take-home paper, I'm going to talk about why do we have these different colors in the periodic table. All of these are one color, and these are a different color, and this looks like a set of stair steps. So we're going to talk about those differences. So these categories, the first one is hydrogen. And hydrogen is in the top left, and it's a little bit of a rebel. So we have to start off talking about one that doesn't fit the rest of the pattern. But for the rest of the elements, we're going to find some patterns. The four outer columns are called the alkali metals on the very far left. The alkaline earth metals are the second column. Then on the far right, you have the noble gases. And beside the noble gases are the halogens. Now, each of these have a similar atomic structure, and that causes them to behave in a similar way. So all of the items that are in the alkali earth metals are very, very reactive. They are so reactive that you will not find them in nature alone. You will find them as compounds, but if they are alone, when we isolate them in a laboratory or in a manufacturing process, they have to be kept under mineral oil or kerosene or in some other form so that they don't react with the oxygen in the air or the moisture in the air. They are very reactive. So the alkali metals, those include lithium, sodium, potassium, rubidium, cesium, and some others. The next ones over are called the alkaline earth metals. The alkaline earth metals are reactive, but they're not as violent as their neighbors. And those include beryllium, magnesium, calcium. You may have heard about calcium as a very important element for our health. Strontium, barium, and radium. The next group I want to talk about is the noble gases. They're on the far right. I told you the alkaline earth metals were very, very reactive. The noble gases are just the opposite. They don't want to react at all. If you remember when we were working with the Make an Atom simulator, that we had a full orbital for helium. That full orbital means that helium doesn't want to share electrons. It doesn't want to react with any other elements. The same thing is true for neon and the other noble gases. Argon, krypton, which is a real element, and xenon and radon are noble gases. The next column in is called the halogens, and they are reactive, but they're not violent. And they often react with the alkalis or the alkaline earth metals to create salts. And some of the ones of the halogens that we're familiar with include fluorine, chlorine, bromine, and iodine. The next set of information I want to talk about is called the stair-step metals, and that's this block over here. The first group is called the other metals, or the poor metals. These are the ones that are in green on your take-home, on your large periodic table, or they're in orange on your take-home paper. And these metals have low melting points. In general, they are softer metals. We've all heard about aluminum, but they also include gallium, indium, tin, and lead. Next item to talk about is the non-metals. They're not halogens, but they're also not metals. They are also very, very important. These non-metals make up 99% of the ocean, 99% of the atmosphere, and 98% of all living things. They include carbon and nitrogen and oxygen, phosphorus, and sulfur. The last category in this group is the metalloids, or the sort of metals. And these are the ones that are in between the poor metals and the non-metals. These include boron, silicon, germanium, arsenic, antimony. These metal materials have properties of both metals and non-metals, which makes them very interesting for making semiconductors, such as are part of our cell phones and other electronic devices. The large group in the center here is called the transition metals, and these have a variety of properties, but they all have that fourth level of orbitals, and they have properties that relate to one another. In that group, you will find things like gold and platinum and nickel and manganese and several other materials that we're familiar with. And then the rare earths is the ones that are on the bottom. These are not very frequently found in nature, and they fit in this category because they're down among the heavier elements. On the page that's labeled Websites for Further Study, it says a game where you can put the blocks in the correct locations, and you have the address for that game. That's what's on your screen right now. So if you make this a full-size screen by clicking on this little icon here, and then click on the green flag to start, or this green flag to start. And by the way, this was written in the Scratch programming language, which does not require you to sign up in order to play this game. And you also do not need a credit card or a registration or to provide any identifying information to run this program. So when you click the Start Game, it says that you're going to use the mouse to move the parts to the correct locations, and then double click to make them settle down once you get them there. So you can see the periodic table was in place, but it fell apart. So I'm going to use my mouse pointer to pick up hydrogen and put it where it belongs, and then double click it so that it'll stay there. And I've now put the halogens in the correct location, and you saw the name for the halogens, and I'm 20% finished. Going to move the alkali metals in place, so I'm going to drag them over here and put them where they belong. They're the alkali metals, and now I've got 30% complete. So you can continue and finish putting the components where they belong, and that's how you play this game. It's not a really complicated game, but it does help you to recognize the different names for the groups, like that's the non-metals. And here we have the noble gases, And the alkaline earth metals, they need to be put in place, and we're still missing the metalloids. And there they are. So we'll settle them in place as the metalloids, and we've now completed the game. Now, if you have time and you want to play this game a different way, then when you start it again and allow it to go through reminding you about the instructions and taking the table apart, you can play level 3. And I'll show you what that looks like in just a few seconds. So if I click on level 3, you'll notice now you have the names for the groups, but you don't have the groups. So if you wanted to put the noble gases in place, you would position the mouse over the noble gases and push that button, and now you've got something you can put in place. So it's similar to the first game, but you get to use the names for the different groups. So again, if you want to play this game, enjoy it and feel free. There's no need to register. The next thing I want to ask you to do is to look at the page that's titled Website for Further Study. At the top of that is the game that we just looked at and played. Below that is some information about the official periodic table from IUPAC. There's also a web page with a periodic table where there are several elements, and you can just click on each one of those blocks and watch a video about that element. So if you wanted to see a video about manganese or about cobalt or about uranium, you could go there. There's also another website that lists examples of the elements and how they are used in nature. So if it's not part of your coloring book package, you can go to that one and learn more about it. There's also some other videos and other lecture notes that you might find interesting. So what have we learned today? Well, we've talked about what is the periodic table. It's a way to organize a lot of information. We've talked about the blocks. Each block represents one element, and everything in the world is made up of elements. We've done the how to build an atom simulation software, where we looked at protons, neutrons, and electrons, and we made stable elements, and we made ions and neutral elements. And we talked about how important the orbitals were. We also talked about the shape of the periodic table and how the different orbital levels cause the periodic table to have this stair-step approach. And we talked about the colors because they represent the different similar materials. So thank you for being a part of our Makerspace. Is there somebody that you could talk to about this? Is there somebody in your class that might be interested? Either one of your parents or maybe a grandparent that might be interested to know something about the periodic table? If so, feel free to share that with them. And if you'd like to get another package from the library so you could share it with them, then make sure you contact the library and let them know. Again, thank you to CLECO for sponsoring our program, and thank you for watching. Bye now.